Assalamualaikum and hi. Today we will present about frequency response of BJT and JFET, and we are from group 3. Alright, before we go further, let me introduce our group member first. My name is Muhammad Syaifuddin bin Asli, and my next group member is Muhammad YUSRI HAFIZ bin YUSLAH, AKMAL HAIKAL bin KALAM, and the last is Muhammad HARIZ DANIAL bin OMAR. Alright, for introduction, BJT and JFET have a frequency response that describe how their electrical characteristics vary with the frequency. For BJT, frequency response have two parts with a low frequency. For low frequency, act as a current amplifier with high gain, and high frequency gain decrease due to the internal capacitance. Cut-off frequency is the point where gain drop to unity. And for JFET, frequency response for low frequency act as a voltage control resistor with high input impedance, and for the high frequency gain a decrease due to the internal capacitance. Input and output capacitance affect behavior. This response depend on specific device parameter, biasing conditions, and internal circuit components. Datasheet provide detailed frequency response information. Alright, next let's look the solution in the manual calculation and simulation calculation. Alright, let's we go for the manual calculations. For manual calculation, determine RE and find the mine band frequency voltage gain. And we need to find the VB, VE, and IE and RE first. So how to do that is VB equal to R2 divided by R1 plus R2 VCC, and we got 4.0 volt. For to find VE, we use the VB equal to VBE plus VE, and we got VE 3.3 volt. For find IE, we'll use IE equal to VERE, and we'll get 1.65 milliampere. And last, to find RE, we use RE equal to 26 millivolt per IE, and we'll get 15.76 ohm. So we can calculate the input impedance by doing the Z output equal to R1 parallel to R2 parallel to BRE, and we get 1.317 kilo ohm. For output impedance, we will use Z output equal to RC, and we'll get 4 kilo ohm. And voltage gain, AV equal to V output equal V input, so we get negative 19. Alright, let's have a look for the next part, which is the cut-off frequency due to the CS. So the cut-off frequency due to the CS, we get 6.86 Hz, and the cut-off frequency due to the CC, you can look for the equations and the manipulation. We will get 25.67 Hz, and cut-off frequency due to the CE, we will get 888.89 ohm. And last, for RE, we get 3 to 6.8 Hz. And the highest of the three cut-off frequency of the amplifier, therefore the low cut-off frequency F for the network is 3 to 6.8 Hz. Alright, this is the graph for the past questions that we have calculated. And next, determine the bandwidth BW. BW equal to FHQ minus FLE, and we will get BW is 695.57 kilohertz. Alright, now let's we take a look for the simulation calculation. And this is the circuit that we have transformed to the manual to the multi-sim software. Let me introduce first the component that we have used. This green is the function generator. Next, we have resistor 1 here, provide 1 kilo ohm. Capacitor 1 here, 10 microfarad. Resistors 2 here provide 10 kilo ohm. Resistor 5 we have 40 kilo ohm. For VCC we have 20 volt here. Resistor 7 we have 4 kilo ohm. For capacitor 3 we have 1 microfarad, and this is the transistor NPN. And R6, which is a resistor 6, we have 2 kilo ohm. Capacitor 2 here 20 microfarad. R3, which is resistor 3, is 2.2 kilo ohm. And the last one, the green one here at the top, is the bot plotter. Alright, now we have take a look for the graph for the high and low frequency response. So after we introduce all the component, and this is the, okay, when you see the green one is 3.32, is nearest to the low frequency response that we have get, which is we get 3 to 6.8 hertz. And for the high frequency response is the yellow one, okay, yellow one, which is we get 6.95, I think. So this is 694.72 kilohertz. So I think that's all for the simulations. So what we can I conclude that the manual and the simulations, low and high frequency response, we get the same one. So I think that's all from us. Alright, in conclusion, the utilization of software tool like Multisim have a significantly enhanced our learning experience and expand our capability in understanding and studying complex system. The integrations of manual calculation and software simulation has proved to be a powerful approach, offering a comprehensive and reliable way to analyze and comprehend frequency response in AC circuits.